so in this video, we'll start where we were cut off last time. I'm going to finish this example. The last part is really to go with this definition that's coming up. Today's video is going to be the first where we actually solve differential equations. Let me start by finishing this. We had this differential equation, we looked at particular and general solutions, but now what I want to do is I want to rewrite this. Instead of the equation having f of x, I'm going to replace it by y. So f prime of x equals f of x plus 5x. I could write this as y prime equals y plus 5x. Or I could even write it as dy over dx equals y plus 5x. All right, thinking of the function as a variable, a dependent variable of x, that's going to be helpful in what follows. So I will often write it this way, dy over dx equals y plus 5x. Now we're ready to define the specific type of differential equation that we'll be solving this semester. So a differential equation is called separable. If you can write it in a way where, let me show you, if it can be written as dy, so that's the y is your function over dx, is a product of two functions, one that only involves y and one that only involves x. So let me use, I don't have it here, so let's just say g of y, h of x. Alright, so let me show you how we will solve these differential equations by starting right now with an example. Alright, so let's see this differential equation. I have dy over dx is x squared over y squared. I want to start by finding the general solution for this differential equation. Alright, so remember from the last video, general solution means a solution with constants in it that represents every single solution that could be out there, every single function that fits this differential equation here. Alright, so the first thing you should do is you should separate your variable. Put all the y's on one side, all the x on the other side. So step one, I'm going to separate the variables. That's where the term differential equation that's separable comes from, is the fact that here I can send y squared to that side, and I'll do even more than that. I'm going to send this dx, I'm going to split it, and I'm going to send to this side, just like we did when we did substitution. say that y squared dy equals x squared dx. And now in the second step, I'm going to integrate this equation here. I'm going to integrate both sides, and if I integrate things that are equal, I should get things that are equal. So y squared dy should be equal to x squared dx. Here I have dy, so that means my variable is y for that integral. So I get y cubed over 3. Here I get x cubed over 3. And don't forget the constants. I have 1 on this side and 1 on that side. So step 2 is integrate. Alright, my goal was to get a function y, so now I need to isolate for y in this. So y cubed over 3, let me send the constants to the right. I'm going to get c2 minus c1. Now this is just a single constant c, so that you can always take care of at the start. You don't really need both c's, you could just use one, as you can see here. Now I'm going to multiply by 3. Let me remove this and you'll see why in a second. If I multiply by 3, I'll get x cubed, and then I get 3c2 minus 3c1. Again, that's just a constant. So at this point, let me take all of this and call it c. So y cubed is equal to x cubed plus c. Now, to get rid of the cube, I'm going to take a cube root of both sides. But now be careful, the cube root applies to this whole thing here. So I'm going to get cube root of x cubed plus c. Alright, so that's a solution for the differential equation that we started with. That's the general solution, since we have the plus c there. Whatever value of c I put in it, I get a particular solution. So part B, sorry, I just lost it, which I probably have it in my notes here. Alright, so in part B, I'm going to ask you to find a particular solution. Alright, so this is the variable, so we get that x equals 2. 0 is the function, so x equals 2 and y equals 0. So I need to figure out for which value c, I could put x equals 2 and y equals 0. So 0 equals cube root of 2 cubed plus c. So if I cube both sides, I get get that c is minus 2 cubed, which is minus 8. So my particular solution here would be this, but where c is replaced by what I got here. So c would be replaced by 8. Alright, so this is the general solution. That's one particular solution. To make sure that everybody gets the same particular solution, I need to give you some initial condition. I need to give you the value of the function at one point.